All right, welcome back. Another day, another dollar. Shout out GitHub followers. I see you. I appreciate you. Gotta make the Pokemon sound of the day. That Pokemon is Nidoqueen. Let's get into that. What? That was just like a roar. You know what I'm saying? Okay, that one was bad. All right, let's get into the Leetcode of the day. That's what I'm here for. What we got? We got cousins in binary tree 2. I haven't done the first one. Wait, cousins in binary tree. Should I do this? Is this an easy problem? All right, let's do both of them first. All right, given the root of a binary tree with unique values. Given the root. Are cousins. 4 and 3. Wait, how is that false? Oh, no, because this needs to be. So same level, different parents. Is that the criteria? Same level and different parents. Because like if there was a, like look at this 5. If this 5 was like here. This is not a search tree, right? Yeah, okay. If there was a 5 right here, they would not be cousins, they'd be siblings. Because they have the same parent. But if they have different parents but on the same level, then yeah, so I think the way I want to, I mean, there's probably a really fast way to do this. But the way I think I'm going to do it is I'm going to traverse the entire tree. How do I keep track of the parent? Like, I think I want a hash map where the key is the, yeah, because we have XY. So the key would be the value. And then the fucking thing is the parent and level or depth. Like that. Oh my god, depth. So if, I'll make this the full word. So if parent doesn't equal each other but depth equals, then it's good. So should I do DFS? What would be the easiest way to get the parent? Probably DFS. Cur, parents, and depth. Let's do hashy. Return. DFS cur.left. Cur depth +1. DFS cur.right. Cur depth +1. We'll do it in order because I'm cool like that. No, I'll do it before. Hashy at spot cur.val is equal to parent dot val and depth. Okay, and then that's gonna run. It's gonna be dope. But dot val. Can it be negative? Can I do lazy? Yes, I can. Nice. Okay, if parents is equal, I'll just do -1. Or I'll just insert a tree node because I'm lazy. Yeah, I'll just do that. Okay. Great. So we'll run that. We'll run that DFS. Here's what I meant when I'll do tree node. DFS root. We'll do tree node. Like, this is what I meant. Like, I'm just gonna do like this, -1. And 0. And that's gonna work wonderfully. And I'm gonna print hashy. Let's just see if look, you gotta go to the bathroom really bad, but I really want to finish this problem. Okay, if hashy at spot x at spot 0 is equal to, oh shoot, is equal to, and this is such an ugly way to do it, hashy at spot y at spot 0, that's the parent, right? Oh no, doesn't equal. And hashy at spot x at spot 1 is equal to hashy at spot x, no, at spot y, spot 1. And I'm pretty sure I just returned this. I don't have to do this, some magic. Let's see if I get errors. No way. I figured this out before I can go to the bathroom. Oh, I'm the goat. All right, be back. All right, gang, we're back. Back in black. And let's just see what other people did on this problem with BFS. Java code. That's not what I asked for. This is far from it. Yeah, I don't know what the fuck's going on. All right, let's just do the next one. Let's see what's going on here. Given the replace the value of each node in the tree with the sum of all of its cousins' values. What? I think I want to do the same approach here, where I just store it in a hash map. Maybe, but I feel like the issue is that the hash map instead would instead the hash map, oh, but that would be n squared. I need to somehow get all of the things. Maybe I just get Man, I really don't know how to do this without making it like n squared. 10 to the 5th. That's not optimal. Cousins is same depth, different parent. There's got to be an easy way to do this. Because my idea is I traverse through the tree once and I just know the depth and the parent of each node. And then I can do that. I can use that information to do it like a lot easily on the second traversal, you know, because I'm at this one. I can look at all the things in this depth. But the problem is it's like I go to this one, right? I check, no, yes. All right, 7. I go here, no, yes. I go here, no. Like I'm repeating work. And it's n squared. It's n squared times like n. It's just n cubed actually, is now that I'm thinking about it. Maybe not. No, it's not n cubed. That's how that works. It's plus n. Yeah, it's just n squared. Maybe, is it parent? What's depth and parent? How the hell do I do this? See, level order, I feel like level order, there has to be some like because how would I use level order to do that? Like I just get this node and then that's it. The queue would have to be like the queue would have to be like deck and then it's like root. But it would be the queue would be the node and then the parent of the node. And then the depth is automatic because, you know. But I'm making a whole new tree. How is this a 70%? Like, this is a hard problem. What? I mean, yeah, we start at cur equals tree node of 0. Okay. I'm just gonna do some do I do it in reverse? Like if I had one of them start here and one of them start here, I would add this, and then they're equal, so I wouldn't. I start here, I start here. Why wouldn't I add them? Wait, I think I have an idea how I want to do this. Hold the phone. Let's try this new idea. So what I want to do is I want to make a new thing right here. But I'm gonna, but that doesn't. Hold on. Do I just want to make two queues then? Rev Q. I'm just gonna try this. I don't care. Let's just try this. This problem is seeming really difficult though. When it's not node, it's rev node. And that way it would just, yeah, do it from left to right. I think this could work possibly. Let's do print node.val. Oh, let's do. Oh, the tree might be unbalanced. I mean, that Loki doesn't explain why I didn't get any print statements going. Oh, it's q.popleft. It's rev q. I still think this is going to error out, though. It didn't, Rev. It didn't do that. That's weird. Okay. Look, 1010. So 5, 4, 9, 1, 10, 7. 5, 9, 4, 7, 10. Yeah, that's right. Okay, if node.val tree node 0. How do I go left or right? I do it only here. Cur equals cur dot left. Cur equals cur dot right. No, that doesn't fucking work anyway. Okay, this is stupid. What am I doing? This is not working. I'm just gonna do my original idea. Even though it's n squared. I just really. Whatever, dude. Let me look at my other one. All right. Do I want to do the same format? Depth? Yeah, I'm just going to do the same one. Oh, and I need to add it to the thing. Whoops. Is it cur.val? Yeah. Okay. So we got that going. And now it makes sense to do a level order traversal. It doesn't really matter which one you do. It's just like, I'm going to do this one. While q for I in range len of q node, we'll do cur equals q. We need a new tree. So head equals tree node 0. Cur is equal to head. We'll do node. Let's go to head cur. So hold on, before I do this, I want to try something. Can I do for parents curval in hashi at spot? I'll do like 2. I'm just curious if you're like allowed to do this. key error. Oh my god. For key in hashy, bro. Does that make you happier? There you go. Nothing was printed. That is not good. Why was nothing printed? Did I call it? No, I didn't. Classic. Zero. Cannot unpack non-iterable tree node object. Oh, parent.val. And also, it's... that. I mean, yeah, that's looking right to me. All right. So I can't unpack it. That's allowed. For... Oh, I need the depth. Okay, so I need cur depth equals -1. Depth plus equals 1. For parents curval in hashy okay, if yeah, why is this problem so hard? Am I tripping? Am I tripping, or is this problem just really hard? If this TLEs, I'm giving up, by the way. I'm just not going to lie to you. If parent curval and hashy spot depth. The problem is... Problem is I don't have the parent of this one. I need the parent of this node as well. Do I run another DFS? Okay. Man, this is just such the wrong way to do it, but. Okay, for parents cur val in hashy at spot depth. Okay, we got cousin sum. Okay. If oh, well, you can't call it parent pair. If parent doesn't equal pair, cousin sum plus equals cur val. Let's just like man. Let's just make sure this is doing what I need it to do. That's not good, is it? I mean, this is working. I just don't understand why. Oh, it's parent.val. Yeah, there it is. Yep. This is probably useless too. Yep. Okay. That's looking good so far. Even though this is like n fucking factorial. Don't worry about it. Okay. So we got node equals head. So node. Is there a way to make... Can I make cur.val is equal to that? It's tricky because of this. This won't work, right? It'd be nice if I can do this in place. Yeah, I don't think you can do this in place because of that problem right there. Maybe if this was after the whole thing. Oh. Oh, that worked? It's gonna TLE, but let's just see what happens. And there it is, bro. And there's that beautiful TLE. We knew what was gonna happen. It's so much pain, dude. Wrong answer. Holy I got the wrong answer? I like don't even believe that. What's the right answer? Wait, what? Where's the wrong answer at? Wait, where's the wrong answer at? It's the same numbers, though. Yo, what? I mean, it's like the same thing. What? I'm asking Claude. It wasn't properly grouping siblings together when calculating sums. The way you stored a parent. Wait, what? Okay, let me just copy paste his solution in. Let's just see if it works. Okay, his worked. What was the fucking difference? What? He had... Level sums dot get depth 0 plus no dot val. No, I don't get it. I think I need to watch Leetcode's video on it. Google, bro. I'm just trying to get a job, dog.
Back and let's write some more Leetcode today. So today let's solve the problem, cousins in binary tree 2. So I'm just going to jump straight into the example because this problem isn't super complicated conceptually, at least. So the idea is we are given a binary tree like this.
Why is it so bad quality?
We want to modify the value of each of these nodes such that we take each value and we replace it with the sum of pretty much every other node on that level. So I'll actually start with this level just to make things clear. This level has a sum. The sum of the entire level is 18. So for each of these nodes, we don't want to replace them with 18. For this node, for example, we want to get the sum of all other nodes in that level except for like the node itself and the sibling of that node. Meaning that like if this and this are sharing the same parent, they are siblings. Now this one doesn't have a sibling, so this one is going to be replaced with the sum of these two. So that's 11. For this one, it's going to be replaced with this, which is 7. And for this one, same thing. It's going to be replaced with this. It can't include this one because that's its sibling. So it'll be replaced with a 7. So that's how we're getting this, this, and this. So obviously, two nodes that are siblings are always going to have the same value after we modify the tree. Now, how exactly do we compute that? How do we know which value is going to go here? Like in terms of the level sum? Well, you could think of it this way. A node is going to be replaced with the level sum minus itself and its sibling, if it has a sibling. So I'll just say minus A and B, and those are going to be the nodes themselves. So this is how we can solve the problem.
Oh, that's what this guy did.
Suppose that we compute the level sum for every level. So it's 5 here, it's going to be 14 here, and then here it's going to be 18. We can do that most easily with a breadth first search, pretty natural tree traversal algorithm to compute this. We could also do it with a DFS, but I prefer BFS in this case.
Same.
So now we are actually going to traverse the tree a second time. And this time, again, we could
so I was on the right track then. Like I was doing it like kind of right, but for some reason my bullshit solution doesn't work.
Either DFS or BFS. I'm going to do BFS just because that's the way we did it the first time anyway, so it doesn't really matter. This time, for every node, we're going to take the level sum minus this value, like the original value in that node, and its sibling if it has one. This one doesn't have a sibling, so this is going to be 5 minus 5, so it's going to get a 0 over here. Then we're going to go here, same thing. The level sum is, it's not 14, it's 13. I'm sorry about that. So 13 minus 4, and it has a sibling 9, so minus 9 as well. We're left with 0. So same thing over here.
Okay, but how are you getting this sibling? That's my question. How are you getting the sibling?
minus 9 minus 4, we're left with a 0. We'll do the same thing for these as well. So you probably get the idea. The only difficult part is for a node, how do we get the sibling of that node? Now, there's multiple ways to do it. We could save pointers. We could go look at the parent and then look at its other child. There are
I don't want to do any of these
different
garbage ways, but what's the easiest way?
In
Let me know.
terms of BFS, the easier way actually is like this. Suppose we're at this node. As we are adding its children to the queue with BFS, that's generally how BFS works with a queue. So that's when we're actually going to update the values of the children, not when we're actually visiting the children themselves, but when we are at the parent. So from the parent's perspective, we can see that we have 2 children. So we can get the sum of those 2 children, which originally is 4 plus 9, and that's 13. And then from that, we can subtract the level sum. Well, we can take the level sum and subtract from that the child sum, and then that'll be the replacement value. So from here, we would see that the level sum is 18. The children's sum is 1 plus 10. That's 11. So we can take 18 minus 11. That's the value that both of the children of this guy are going to get. So
I'm going to attempt to solve this without looking at his solution because I'm a savage. Classy, bougie. Sorry, I don't know what I'm doing. All right. Where to go? So we're going to need a hash map of... it's still the same thing. It's depth, but to level order sum. Okay, so Q equals dec root for while Q, we need a depth. Cur sum, cur level sum. And I was so close to solving this one too. That's actually such a tragic. Like, I'm actually kind of sad at that. Okay, 5, 13, nice. Okay. Now we're gonna do it again. So Q equals dec. Wait, hold on, let me just do it like this. Yeah, this still doesn't make it that much sense though. Like, so like wait, for I in range len of q. Node recur equals q dot pop left. I don't know why I call it cur, bro. I like the word node so much better. All right. So now we have this, but the problem is it's like, okay, well, if depth is equal to 0, cur dot val is equal to 0. Okay, elif, the depth is not. Okay, now we do it from here. We do sum of child ren is equal to, okay, C1 is equal to cur dot left dot val if cur dot left else 0. C2 equals cur dot right dot val if cur dot right else 0. Okay. So if cur dot left dot val is equal to but then it has to be +1 though. Because we're doing these ones. So now we're at 0. Now we need to be 1. But when we get to here, 0, 1, 2, it's going to check for 3. That means we need to stop 1 early. So let's do new depth. Man, this is just such an ugly way of doing it. Like, if new underscore depth is equal to depth, just break. And then we return root minus C1 plus C2 q dot append cur dot left. Okay, what's wrong with the solution? Key error. Fuck, I knew it. Okay, print depth +1. It's 3. 1, 2, 0, 1, 2. Wait, what? Oh, it's depth +1. It's new depth +1. Oh, that's looking good so far. Damn, that was fast. I'm not gonna lie, guys. That was really freaking hard. That was really hard. But we did it. Okay, let's look at his code before we go on to the project.
Oh, there's multiple ways to do it. Let's code it up. So this will be a nice two-phase algorithm where we will first compute all the level sums into an array. So let's do a BFS for that. We will create a deck and we will initialize it with just the root. I just realized I didn't really explain too much what BFS is. I have plenty of resources on that. I have plenty.
Oh yeah, you accidentally forgot to explain what it is. Here's my course. Nah, we love Leetcode, bro. He can plug his course all he wants.
You have YouTube videos, and you can also check out this course where it goes through.
Listen, I think, okay, I'm getting kind of sidetracked here, but like, there's like a lot of grifters on the internet selling courses, you know what I mean? About how to make money and stuff. But someone like Leetcode, and like, he's not making a course on how to get rich. He's making a course on like technical concepts, you know, that like you learn in school and stuff. It's not promising that you're going to get anything out of it. You're only going to get the knowledge that you put in, you know? So it's like kind of different. Like I'm just not a fan of people selling courses, but
pretty in depth, has a lot of like animations.
I feel like
and all that
this
stuff.
is a little different.
So you might find this useful if you're a beginner. But continuing,
I'm not a
we
beginner,
can
I'm an
say
expert.
while the queue is non-empty, we are going to compute the sum at the current level. We'll initialize that to 0, and we'll say, okay, for every node currently in the queue, so we're going to take a snapshot of the length of the queue. So just to go through every node in the current level, we're going to pop q.pop left. We'll get the node. We will take the node's value and add that to the current sum. And after we're done computing the current sum, we will append it to the level sum like this. And we need to continue the BFS here. So if the current node has a left child, we can say this, append it to the queue. And we can do the same thing with the right child. If it has one, we can append it to the queue. So that's pretty much it for the BFS. The reason I can do it so quickly is because I've written this like probably over 100 times. So it just comes with practice. And now let's do the second phase, where we are going to take for every node and replace it with the level sum minus the node and its sibling. There are many ways to code this up in Python. I'm going to first do it this way, and I'll show you like the other way as well. So let's say we have a deck. I'm going to append to that queue just the node. But actually, if I do it this way, if I have the node and the sibling sum, like the child sum of that node and its sibling.
Yo, chill. I'm just trying to figure out how I did it, bro. Dude, why when I click on this, it takes me to this submission detail shit? I'm not trying to look at all that. You get what I mean? Yeah, I did it how he's doing it right now.
Then it's pretty easy to code it up. So we can add a tuple here.
Wait, what?
Where the node and the child sum, and for this node itself, it's just going to be the value because it doesn't have a sibling, of course. Now, coding it is going to be very easy.
Oh, I just use a hash map.
We're going to keep track of the level. Initially, it will be 0. And I'll say, while the queue is non-empty, again, I'm going to go through every node currently in the level. So snapshot of the length of the queue. I'm going to pop from the queue, and this time I'm going to get 2 values. I'm going to get the node, and I'm going to get the child sum value. So that's
quite
what I'll call
Alabama
it. Actually, I'll call it value for now. So we're going to replace that node's value with the level sum at the current level, like this, subtracted from it that other value that we just popped, which is like the sibling sum pretty much. So actually, I'll leave it as val, but probably a better name for it.
Oh, he doesn't have ugly ternary operators like
val. Now, for our children, we want to continue the BFS. So we're going to have a couple if statements like these. So I'm just going to copy and paste these for now. But when we append to the queue now, we're actually appending a tuple. So to this tuple, I want to not just append the node, but I want to append the sum of this node plus its sibling, if the sibling actually exists.
Yeah, how would you do
so
that?
both of these are going to get the same value. the second value appended to them if they both exist, assuming. And let's call that the child sum. So I'm going to put that here, and I'm going to put that here. Now we just need to compute what that
he
is.
did do it.
I
Like
will
that,
initialize it to 0. And I'm
Right.
going to need a couple if statements
oh my God.
to compute it.
Oh my God.
If the left child exists,
I did it like this.
we will add to it the value of the left child. So let's say child sum, add to it node dot left dot val. And then let's do the same thing for the right child as well. So we're doing this from the perspective of the parent, because from the parent we have access to both of the children. But from the left node, we would not have access to its sibling, the right node. So here I'll change that to a right. So with these two if statements, we will compute the child sum, and then we will append the child sum here. Unfortunately, we can't combine these if statements very easily, because we need to compute the sum before we can execute either of these, and we only want to execute each of these if that node actually exists. So I think this is like a sufficient way to code it up. Last thing down here, let's not forget to increment the level. And then down here, we are just going to return the original root of the tree. We already modified the value of it, so we should be good.
I save...
this is pretty much the entire code, so I'll go ahead.
I don't traverse the last level.
Ahead and run it.
Because I'm a genius.
And you can see here that it works and it's efficient. I will show you a slight variation of coding it this way if you don't want to append a tuple.
Okay, whatever. I think I understand what's going on with that. All right. That was a tricky problem, though. I'm not even going to lie. That was kind of hard. All right, let's move on to the project. The project. Oh, my God. Oh, my God. Okay. So I think we just finished the playlist situation. Now, what do I want to do? I need to mute the thing. Oh, I'm so cold, guys. I'm so cold. Yes, this is what I got so far. Let's have a button for next. Oh, but it doesn't, we're not in the current playlist. Okay, so what should I do next? Okay, I think I need to create a new VBox on the left here with the playlist. The one you're currently in or something. Or like drop downs or something. I don't freaking know, dude. This project's just super hard. Especially with JavaFX when I have no idea what's going on with JavaFX. This probably would just be an HBox. HBox root equals new HBox. Call this main. Does that work? It does, yeah. Okay, so now I want a new VBox. Here we'll call it main controls. All right, so I want a thing on the left of all the playlists. Which I should probably do in here. Public HBox. Okay. Should I do it like this, or should I do it as like a... So just call it layout, right? Okay. Oh, I need a name to the playlist too. Okay. Label, playlist. Wait. Label, title. Dude, how do I do this? I'm gonna be working this project for the next like month, dude. I swear. How do you do labels in Java effects, dude? Label, basic label equals new label. Okay. Can I, is it play? It's layout. Okay. Okay, 4. Okay, how do I do this enhanced for loop, bro? Oh, the song needs a fucking get name function. I guess it's just .toString. Is this fire? Okay. Hey, why is it an H box? It needs to be a V box, not an H box. V box. Okay, let me go to here, and then it's what seems to be the problem, officer? Layout's null. Oh, it's never assigned. Oops. Does it need to be assigned? So the issue I'm seeing is that it's not. Where is this being printed? Where? Get metadata.toString. Okay. Is that never running? Just that get size. What? Oh, because playlist is not a... Yeah. Zero. Okay, well, that would explain that. Why? Did I not add to it? I thought I did. I add song. Yeah. The fuck? Alright, I think for now, can I add, oh god. For now, maybe I'll just give it a name. String name. I never initialized it. Bro, what the do I have a next song in here? Play song. Should this be being handled inside the playlist though? Yeah, why not? Oh, and then I can hit play song. Oh my god. Oh, that's fire. Wait, and then if... Wait, actually, look at this clean code, bro. Clean code. Okay. Um... Should these... What should these be? I don't know what they should be. Because it needs an index. That's the problem. Let's initialize to 0 right here. So that should just work then. I can just go playlist dot play song. But it needs an index. Why do I need this int here? Play song current index. I guess that's why. So do I want to overload this function then? How do you format? Format shortcut in. What the hell? Control Alt L. Nice. Nice. So then this works. But this would restart it every time, I think. I don't know if this is the best way to go about this. Let's just test it out. I don't think this is going to work, though. I forgot to add the button. There's like this weird stutter. But I don't get it. When I had like... When I had song.play and song.pause, we'll just add it to the thing. Like this worked. Like I swear it went to the next one. Or maybe not. I need a listener then in the playlist. I think a listener in the playlist that. But how is it getting its songed up? Maybe I need a current song. I need a return current song. That's probably it. Public void current song. And it's also not void. It's it returns a song. Return playlist dot get current index. So it's playlist dot current song dot. Okay, that has to work, bro. That has to work. Let's try that. That shouldn't have any stuttering. They're still stuttering. Why is there stuttering, dog? Okay, so a couple issues. It's stuttering every time I pause to play, and the next song doesn't stop this song, which is bad. What problem do I want to fucking tackle first, bro? Okay, I'll tackle the stuttering problem next. I need the next button to work. Is there like a reset button in the song one? Get playtime. So maybe like a public void reset. Oh, it's just stop. I don't need to do this. It's just stop. Right, and then none of that. Okay, that's bad. It worked though, but the problem is the playback bar does not. It does not play nicely with the playlist. It's not connected, which is bad. Which means this probably doesn't need to be here. It probably needs to be. How do I put it there though? It should probably be here then, no? Oh man, the design choices of this app is so freaking hard, dude. I think the playback bar should be here. Private playback bar. Playback bar. And each song has a playback bar. Does that make sense? Does each song having a playback bar doesn't make sense? Or does each playlist having a playback bar make sense? I feel like it doesn't make sense for each song to have a playback bar, but at the same time, it's the easiest to implement. Maybe it should. Yeah, I think it should. You know, I give up. I think it should. Okay, this. Song. Player, media player. Song player. This has to be a match made in heaven, right? Like, there's no way. I just need to figure out the best way to display it. Okay, so let's go into here. Let's get rid of this. See, it's playlist dot current song dot get playback bar dot. See, this is how it should work. But this is like, man, this boilerplate is just brain dead, bro. Like, playlist dot current song. Wait. What is scroll bar? doesn't reset it. Because this is the start. This only runs once. That's the problem. This doesn't reset. I'm gonna use the bathroom. Be right back. All right, we're back with 4 minutes left. I really want to get this solved. So the problem I'm running into right now, guys, is when I play, like this is working, but when I click next song, the next song is starting. But this has nothing to do with it, and then this has nothing to do with it. Like when this song or this one starts. So the playback bar and the volume bar have nothing to do with the playlist, which is bad, right? And that's really bad. I think the song needs to have its own VBox then. That's the problem. All of this needs to be moved into the song, like folder or whatever the fuck. Into here. So like private VBox. Layout, I'll call it layout again. Does it need to have, can it just be like this? No. Okay. Thing is, I need to like public get layout, return layout, but the problem is I need all these private methods in here, like private. No, it's already there. It's just like label play equals new label. Jesus Christ. Play song. Label stop equals new label or pause song. It's already 10:30, dude. This project takes forever. I'm looking gonna. I don't want to be late for class. I'll probably come back from class and do a quick Leetcode so I can hit 2 hours. My goal is to get to 3 hours every day, which I have no idea how that would work, but okay, let me just get like all of this. Hold on. But like, how would this be in here? Like, how would I have a label next or next song? Like, how would this work? The problem is it wouldn't. That's the problem. The play and pause makes sense for it to be in the current song. Maybe I'll keep that there. But then this needs to be in the playlist class. Can I do that? No, I can't. Okay, man, this project's hard. I didn't think it was gonna be this hard. I'm not gonna lie. All right. Peace. All right, we're back from class. Let's do one more Leetcode so we can get to 2 hours. Let's do a medium. I don't want to do DP today because that will take a very long time. And I'm just trying to get like an easy medium. Holy fuck. So yeah, let's go to like 5. Let's go to 6. Let's go to 7. Let's go to 8. My lucky number is 8. No cap. Map some pairs. That sounds like a good problem. Okay, design a map. Okay, I'm not designing anything, bro. Implement a magic diction. You know what? I will design a map. Returns the sum of the values that have a key with a prefix equal to a given string. I mean, I think I know how I would do it, but like... Returns a string key. I mean, but I fear this is gonna TLE. At most 50 calls. What is 50 times 50? I mean, it won't TLE probably, but this feels like something I'm doing it wrong. Because what I want to do is here, the key, it's going to be the word and amount or val or whatever. So it's going to be key plus equals val else self.hashy. And then I'm just going to like loop over all the keys. So for key in hashy, in self.hashy, res equals 0. If len of key is greater or equal to prefix and key at spot len of prefix is equal to substrings in Python. It's like this, right? Okay, so why is this not like is this right? Oh. Whoops. This is not a real problem, dude. Wait, why is it 4? Does it replace it? Me when I don't read the fucking directions, bro. Bro, I don't need any. This problem is just easier then. This problem is easier then. Bro, what? This is not a medium. Okay, I said I was going to do a medium easy, but this is like not a medium at all. Is this like harder in other languages? Like I'm trying to think some of these problems are just like way harder in other languages. Try. Is that how you're supposed to do it? See, that would make sense. The wording in okay. How? So I guess implementing a tree or a try is the way to do this. Because I don't think I did this problem right. Because the way it's supposed to work is this problem is supposed to work, guys. Before I get a comment saying, "Oh, you did it wrong," like, okay, I know I did it wrong. But like if we take this one for example, it's here we got A. Here, let's do black. Okay, we got A, P, 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 L, E. The way this problem is meant to work is that A has a value of A, so A has a value of 5, value 5, value 5, value 3, value 3. And let's say you inserted like, I don't know, what another words that start with A but that don't have the second letter P, that aren't like 400 letters, are the letter A or the word ARE. So ARE, and let's just say ARE. Oh my god. Dude, I need to hook up my iPad to this thing so I can draw. I inserted this, right? Into this thing, right? A would be 5, 6, 7. This would be 2. This would be 2. This would be 5. This would be 5. This would be 3. This would be 3. Oh yes. And you would like connect them shits. Horrible drawing. But the point is, it's like you would get like, so you would get some AP and you would start at A and you would go to P. Like if you can, you'd go to P and then you would just return whatever P is equal to. Wait, can I implement that in this problem? I'm just realizing this probably actually isn't that hard to implement. Oh no, because it's connected. So you can't just do that, what I want to do. All right, I need to do a try problem, dude. I'm not even joking. I need to implement the stupid try. Because this is supposed to TLE. This is not supposed to pass. I'm going to look at the try problems. See what they got going on. Oh, and there it is. Try node. There you go. Self.try. Or ch in key. Okay, for char. Node.set default. What does that do? Huh. Well, that's going to be it for me today. Peace.